Algebra 1, Lesson 103, we are dividing radical expressions. So we've looked at these fractions before, but now grammatically we need to change some of our radical expressions to no longer have radicals in the denominator. So we are using this quotient property of radicals, saying if I have the square root of x over y, that is actually the square root of x over the square root of y. And of course, y can't be 0. So radical expressions can't have a radical in the denominator in order to be simplest form. Just like we want to simplify fractions, just like we want to get rid of negative exponents, it's just not grammatically correct in math to have radicals in the denominator. So we need to get rid of them. And in order to do this, we first need to use this quotient property of radicals to say the square root of 7 over the square 7 over 3 is the square root of 7 over the square root of 3. Now, in order to get rid of this square root of 3 on the denominator, well, the only way to get rid of this radical is to multiply by itself. Because if I were to multiply this denominator by the square root of 3, the square root of 3 times the square root of 3 is just 3. But we can't just multiply the denominator by root 3, we have to multiply the numerator as well. Because if we multiply by root 3 over root 3, that's just like multiplying by 1. So in order to get rid of this radical of root 3, we multiply by itself. We end up getting that the numerator, we can multiply that, radical by radical is root 21 over, well, square root of 3 times square root of 3 is just 3. You can see that by saying, well, that's root 9, which is just 3, or square root of 3 squared is just 3. So when we do it for the second one here, root 15 over 2, we split it up to say this is square root of 15 over the square root of 2, and then we multiply the square root of 2 over the square root of 2. So we say this is the square root of 30 over 2. And there's nothing else to simplify here because the square root of 30 is in the most simple form. All right, let's try it again. 1 over root 8, and then we'll do 2 over root 18. Now, in this one, we don't have to actually split it out because it already is, and we're just going to multiply by root 8 over root 8. And we get the square root of 8 over 8, but that's actually not in simplest form. The square root of 8 can be simplified to 2 root 2 over 8, which this 2 and this 8 can simplify to just be the square root of 2 over 4. And similarly, down here, I'm going to multiply by root 18 over the square root of 18. It gives me, well, since 2 and root 18 are not both radicals or not just both whole numbers, I can only say this is 2 times the square root of 18 over 18. Well, the 2 and the 18 can simplify, but that square root of 18 on the top can also be written as, in simplest form, 3 root 2 over 9. Which now the 3 and the 9 can cancel, and we get a very simple form of the square root of 2 over 3. Now, in addition to this being grammatically correct in math, it's much easier to take something like the square root of 2 and divide by a whole number, so taking a lot of decimals, okay, 1 point something 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 divided by 4, that's much easier to do than taking 1 divided by some amount of decimals. Okay, 2 point something something something, that is the square root of 8. It's much, much easier to take that decimal and divide by a whole number than take a whole number and divide by a decimal, and that's why we do it. Now, there's another part of this, and this is when we have binomials. Okay, so let's look at this. You can try these on your own, but it ends up the same. I'll get to the binomials in a second. I guess I'll show you an example of this. So we split it out to be root 5 over root x, and we multiply by the square root of x over the square root of x. That's the only way we're going to get rid of it. And we get the square root of 5x on the numerator, and we just get x in the denominator. Because remember, if this were root 3 times root 3, this would just be 3. So root x times root x is just x. And the second one over here, you can try it on your own, but you should get an answer of root 7y over y. Now, in each of these, since there's a variable in the denominator, we should exclude some different values. So x can't be 0, y can't be 0. All right, now to these binomials, because we won't always have just one variable or one term in the denominator. And now what we have to use is called a conjugate. And so if I have something like a plus root b, that has a conjugate of a minus root b. The reason being is this. Let me give an example here. If I have 3 over 4 plus root 5, and I need to get rid of that root 5, well, I can't just multiply by square root of 5 over square root of 5, because that would just give the root 5 to the 4, and that's not enough to make it in simplest form. I have to multiply by the conjugate. So if I did that, if I have 3 over 4 plus root 5, and I multiply by the conjugate of 4 minus root 5 over 4 minus root 5, what that does is this. Now the numerator is pretty easy to see. We do some rainbows here to get 12 minus 3 root 5 over, well, let's actually multiply this binomial out. So I'll do a box here, and I have 4 plus root 5 and 4 minus root 5. I get 16, I get 4 root 5, I get negative 4 root 5, and lastly, I get a minus root 25, or just minus 5. Which means that this 4 root 5 and negative 4 root 5 end up canceling each other out, which is exactly what we want. We don't want any radicals, and we end up seeing that it's just 16 minus 5, which is 11. So our conjugate ends up canceling out the radical here because it is a difference of squares. Okay, so let's try that again. 4 over 2 plus root 10. So I'm going to take this 4 over 2 plus root 10, and I'm going to multiply by 2 minus root 10 over 2 minus root 10. Now this is a difference of squares in the denominator, so really I'm going to have 2 squared, which is 4, minus root 10 squared, which is 10, over, well, I'm going to expand here and get 8 minus 4 root 10. And I can simplify this to negative 6. Now we look at this and I see 8, 4, and negative 6. They all have a factor of 2, so I'm going to actually factor here, get it a little simpler. So I'm going to factor out to 2 and get 4 minus 2 root 10 over negative 6, which means I can simplify this to negative 3 on the denominator. And I get an answer of 4 minus 2 root 10 over negative 3. So make sure that you're factoring and simplifying as well. All right, another one. 2 over root 3 plus 1. All right, so I am going to multiply by root 3 minus 1 over root 3 minus 1. I get 2 root 3 minus 2 on the numerator, and I get, well, root 3 squared minus 1 squared, so 3 minus 1, which is just 2. Okay, and then I can simplify this. I can factor out a 2 and get root 3 minus 1 over 2. They simplify, and I just get square root of 3 minus 1. All right, I'll leave this one for on this other side for you to try. Think about that conjugate and what you need to multiply by here. Okay, and here are some other examples that you can try. Now, I skipped a page up here, and let me just go back to how sometimes we have to do some simplifying first before we can use that radical to simplify the most. So I'm going to simplify the square root of 72 x to the 4th. Now, think back and maybe watch a video in the past, and we end up getting 6x squared root 2 over 6x root 5x. There we go. All right, and that comes from putting it in its prime factorization, circling and popping, things like that. And we can simplify these 6x's, and we just end up with 1x in the numerator with that root 2 over root 5x. And we multiply by root 5x over root 5x. And we get x root 10x over 5x. One last step to simplify. Get rid of those x's, and we get the square root of 10x over 5. Okay, you can try the second one as well, but simplify down as much as possible. All right, well, I hope this helps for your homework and for studying.